Okay, so chapter 5 is about energy and how we use energy in biological systems. So before we get going, we need to define a couple of terms, and the first of which is energy. And energy is just defined as our capacity or ability to do some work. There are two types. There's kinetic energy, or the energy of movement, and there is potential energy, which is determined really by the state or position of some substance. So we can think about this poor little fellow who's pushing this ball around. When he gets the ball to the top of this hill, that ball is naturally going to roll down by itself. That rolling ball represents kinetic energy. But at the top of the hill, that ball represents some potential energy. It's not doing something yet, but it potentially could. And the amount of energy that represents really will be determined by how high that ball is relative to its endpoint. If that ball starts way up here, it's going to generate a whole bunch of energy. But if we start that ball right here, much lower down on the hill, then it's not going to generate as much energy. Now, the study of how it is that energy flows is called thermodynamics. And we're going to talk a little bit about thermodynamics and specifically two laws of thermodynamics. But before we do that, it's important for us to understand how it is we use energy in biological systems. Generally what happens is we're taking one form of energy and we're converting it to another. The process by which we do that, however, is called a chemical reaction. Now, chemical reactions either make or break chemical bonds. At least we'll use that definition for the sake of this class. So think way back to chapter 2 when we were talking about chemical bonds. And we talked about them in the context of storing energy. And the amount of energy they could store, or rather their potential energy, was determined by how strong the bond was. So the strongest of the bonds that we talked about, covalent bonds, stored lots of energy. The weaker bonds, things like ionic or hydrogen bonds, stored some energy, but much less. So when we're taking like a sugar molecule and we're generating energy from it, really what we're doing is we are breaking bonds between adjacent atoms and harvesting that energy and converting it into something a little bit more useful to us. Now there are two laws that we need to be familiar with. The first of which states that our universe is really a closed system. There's a finite amount of energy, and it can either be created nor can it be destroyed. But we can convert it. So we can take one form of energy and convert it into another. Plants do that all the time, right? They take solar energy and they convert it into a chemical energy, sugar. That conversion process, however, is not perfect. Anytime we convert energy, some amount of that energy is lost in the form of random energy, which is heat. The second law states that all organized bodies tend towards disorganization. That's the process of entropy. So eventually what's going to happen is all of the organized forms of energy that we have, all of the biological molecules that have chemical bonds that are holding them together, are going to fall apart. And all of that potential energy is going to be lost in a disorganized state in the form of heat, which will make our universe uninhabitable. So that's the second law of thermodynamics, that all organized forms of energy, all organized states tend towards disorganization. That process, again, is called entropy. Okay, so this is where we're going to stop for right now. This is as much as I discussed with my face-to-face class. So we will pick this up again on Wednesday.